Hi class, this is Abby and Palak's data culminating project on urine analysis and what your urine says about your health. The analysis of one's urine is one of the most effective and informative ways to diagnose a person's overall health. A dipstick test can help athletes self-diagnose themselves about their macromolecule intake, specifically carbohydrates, proteins, and fats. The purpose of this experiment is to explore the correlations and trends observed through various macromolecular levels in urine in the hours of exercise per week. Part A, presentation and analysis of data.
Whether it is the form of bothersome UTI or life-threatening kidney cancer, a basic dipstick urine analysis is the fastest, easiest, and the most affordable way for doctors to check the body of any illnesses. The research in this field of urology has made a vast impact on individuals struggling from chronic kidney diseases, diabetes, urinary tract infections, and several other disorders within the body. The study of urine also contributes to analyzing other bodily fluids to diagnose health conditions. Overall, the data obtained from this experiment contributes to the research and development in the field of urology as doctors, statisticians, and patients alike work together, building a healthier, happier future.
So our experimental question was, does vigorous exercise affect the amount of macromolecules in urine? And if so, do the results allow doctors to use dipstick tests to prescribe exercise dependent on the health of the individual? So our hypothesis was that there is a correlation between protein and exercise, and that vigorous exercise may increase the amount of both protein and ketone levels in urine. Results in this graph prove that protein in urine and hours of exercise per week do have a strong quadratic correlation, and this can be seen through the R-squared value of about 90.7% that you can see through the light blue line. As the amount of exercise per week increased, the concentration of protein in urine also increased, and vice versa. Outliers included subject 27, who had a urinary tract infection, and subject 28, who drank a protein shake and worked out right before the test. Due to the scarcity of these outliers, they did not have any significant effects on the results, and they were not included in the graph that you see here. However, the graph proved the original thesis to be true, as vigorous exercise does increase protein excretion. However, it cannot provide information regarding the most ideal exercise duration for a person, as each person varies depending on their lifestyle and diet. Nonetheless, this data provided valuable information regarding the validity of other studies supporting the correlations of protein excretion and UTI infections.
This graph shows the correlation between ketone levels in urine and the amount of exercise per week through a combination bar and line graph. This allows viewers to easily see the moderate correlation between exercise and ketones in urine. The ketone levels in urine gradually increase when a person exercises due to a shortened supply of carbohydrates in body. However, the high carb diet in a subject brought forth very low ketone levels despite high intensity workouts. Interestingly, the low linear correlation seen in the second graph proves that there are other external conditions that affect the results, such as diet. This can be seen in the low R-squared value for factors such as diet, lifestyle, even cultural differences. The mean and median value is fairly inaccurate due to the repetitiveness of the mode, leading to the data being skewed to the left of the median, which is 0.3 grams per liter. The mode 0.15 grams per liter composes 28% of the data, making it most accurate single variable measurement of ketones in urine.
Errors. Unfortunately, we did not have proper equipment when studying the urine. Had we had better equipment as far as measurement, as well as more reliable dipstick tests, potentially from a hospital or another professional establishment, our results may have been more accurate. Of course, there is no such thing as a perfect student or a perfect sample, so there were several variations in diet, exercise, BMI, and stress that may have altered our results. We did have an insufficient medical history as well, as samples with a history of renal disease, high low blood pressure, diabetes, cancer, and other disorders within the kidney may have caused protein and ketone level excretion to be higher than normal. We did have an insufficient sample size and variation as well, due to the fact that we only had about 20 to 30 samples, all of which were within the ranges of 17 to 18 years old, and all were relatively healthy. Part B, probability distribution and predictions.
So for binomial distribution question, a research was conducted in the University of Toronto pertaining the amount of ketone found in an individual's urine. If the researchers used 30 samples and the probability of having no ketones in urine is about 35%, what is the probability that at least one person will have more than 0 millimoles per liter of ketone in their urine? So it was predicted that the vast majority of sample will have a ketone level higher than 0 millimoles per liter due to the nature of the sample tested. All subjects were within the age of 17 and 18, with none that were particularly overweight, underweight individuals. Although 85% of the individuals will not have ketones, the probability of having at least one young person will have more than 0 millimoles per liter in this project will be over 99%. So during our calculations, we used the success of having ketones, which is 0.15, and our failure was having no ketones, which was about 0.85. Our x was represented as 1. So basically, during our calculations for the probability of having at least one person, we took the probability of having no individuals with ketones and subtracted it from the probability of whole, which gave us a number of about 0.99237%. 237. Therefore, there is a 99.2% chances of having at least one person with ketone more than 0 millimoles per liter. For our normal approximity question, in a research paper prepared by Ms. Khalil, it was found that 18% of the students on a college campus have protein levels lower than 0.882 grams per milliliters. The study tested 300 college students. That is, what is the probability that the study will have at least 36 people that have a protein level that is lower than 0.882 grams per milliliter? So it was predicted that since there is 18% chances of success, and the question is in regards to 36 people out of 300 people, the probability of success will be relatively smaller, value estimated around 2 to 10%. The mean calculated will also have an effect on the probability because the mean is relatively bigger than the x. Since the people which the probability asked for is 36 and also will cause the probability of 18% in population is smaller in the sample, leading to the probability of success of if 36 individuals make out of 300, making it already smaller.
So in our calculations, we again calculated the number of successes and failures, which were 0.18 and 0.82 respectively, as well as the number of samples, which was 300, and our x value, which was 35.5, because it was discrete and we used intervals. In using these values, we calculated our standard deviation using the equation you see here, which gave us 6.6543. In using the standard deviation, we were able to plug these into our z-score and get a z-score of negative 2.78. By using the z-score table, we were able to find the probability, which is approximately 0.0027%, or 0.27. Therefore, the probability of having less than 36 individuals that have a protein level lower than 0.882 grams per milliliter in their urine is about 0.27%. Therefore, proving that our calculation is correct. A little bit off due to the fact that we originally had perceived that it would be within the range of 2 to 10%, but again, it is quite a low percentage.
So for hypothesis testing, our question was according to the U.S. National Library of Medicine, the average amount of protein found in urine is about 10 milligrams per deciliter. The organization claims that the mean protein level is about 10 milligrams per deciliter and the standard deviation is about 2 milligrams per deciliter. In a research product, project done by this year's graduating class, they asked 28 individuals to perform a urine analysis, and the mean of their research was about 9.821 milligrams per deciliter. Do these results prove that the claim made by the U.S. National Library of Medicine is true? So it was hypothesized that since the average of the results conducted was so close to the claim made by the organization, the outcome will be relatively close to the expected value. It is predicted that the probability will have a margin of error of about 10% due to the fact that the research was conducted on such a small sample. The probability of obtaining related results to the experiment will not be small. It should also be taken in account that the claim made by the company were on a larger scale, which means more individuals were taken in account. Which means the mean of the population will be higher. Will have a higher level of accuracy. So our null hypothesis was about 10 milligrams. Our alpha hypothesis was less than 10 milligrams per deciliter, and a decision rule alpha was about 0.05. And the mean of the surveyed sample was about 9.821 milligrams per deciliter, assuming that the claim made by the company is accurate, calculating the probability of 9.821%. So
in calculating and you getting all of these samples and values, we calculated we would need a probability of x being less than 9.821, which was the original mean given. And by using these results and calculating z-score, we got negative 0.47. And in using the z-score table again, we found our probability to be 31.92% of people will have 9.821 milligrams of deciliters of protein in their urine. Since 31.92% is greater than 5%, which was our alpha, we cannot accept the null hypothesis. And in conclusion, the research conducted by this year's graduating class can accept the claims made by the U.S. National Library of Medicine due to the fact that their results were significantly off from the original data from the U.S. So in our conclusion, the data retrieved from this experiment did prove our original hypothesis. As seen through the graphs above, protein excretion does increase with a strong quadratic correlation to the amount of exercise per week. Adversely, ketone levels are only weakly affected by exercise due to other external factors such as diet, lifestyle, weight, etc. This experiment also proves that macromolecule contents in urine are not related to finding the healthiest amount of exercise for an individual. However, patients are recommended not to do any vigorous exercise at least 24 hours before their urine test. These questions, along with further studies with pH and glucose, which can also be found through the dipstick test, can be explored further in future reports. Thank you for listening. This is the end of our presentation.